Testing, 1, 2, 3, testing, 1, 2, 3.
بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين. بسم الله الرحمن الرحيم وقال ربكم ادعوني أستجب لكم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين. اللهم إنا نستحفظك ونستودعك أدياننا وأنفسنا وأهلنا وأولادنا وأموالنا وكل شيء أعطيتنا. اللهم اجعلنا وإياهم في كنفك وأمانك وعياذك من كل شيطان مريد وجبار عنيد وذي عين وذي بغي ومن شر كل ذي شر إنك على كل شيء قدير. اللهم جملنا بالعافية والسلامة، وحققنا بالتقوى والاستقامة، وأعزنا من موجبات الندامة، إنك سميع الدعاء. اللهم اغفر لنا ولوالدينا وأولادنا ومشايخنا وإخواننا في الدين وأصحابنا ولمن أحبنا فيك ولمن أحسن إلينا، والمؤمنين والمؤمنات والمسلمين والمسلمات يا رب العالمين. اللهم إني أعوذ بك من البرص والجنون والجذام ومن سيء الأسقام. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار، والحمد لله رب العالمين.
Bismillahirrahmanirrahim. His Excellency Professor Datuk Dr. Muhammad Ikhwan Haji Toriman, the Vice Chancellor of UKM, His Highness Professor Dr. Raja Effendi Raja Ali, the Dean of the Faculty of Medicine, UKM, the Honorable Dr. Muhammad Haikal Muhammad Yunus, Chairman for the 23rd Medicine and Health Research Week, our distinguished guest, the Researcher of the Year, distinguished professors, fellow lecturers, and participants, ladies and gentlemen. I greet you with a warm greeting of peace. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. On behalf of the organizing committee, we wish to extend our warm welcome and thank you to all the participants to this year's 23rd Medicine and Health Research Week opening ceremony, a program that spans for 2 weeks that surely be fruitful and engaging to all participants. I am Dr. Muhammad Luqman, your official MC for today's opening ceremony. To begin this event, we are pleased to invite our Dean of Medicine, Professor Dr. Raja Effendi Raja Ali, to deliver his welcoming remarks. Please join me welcoming our professor to the screen.
Bismillahirrahmanirrahim. Sound check, Dr. Muhammad Luqman, can you hear me? Bismillahirrahmanirrahim. Terima kasih Dr. Muhammad Luqman Nasaruddin, pengurusi majlis. A very good morning and Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Professor Dr. Technologist Dr. Muhammad Ikhwan Haji Toriman, the Vice Chancellor of University Kebangsaan Malaysia. Deputy Deans, in particular Prof. Tan Giok Chin, Deputy Dean for Research and Innovation. The Chairman for the 23rd Medical and Health Research Week for this year, Dr. Haikal Muhammad Yunus, all the Assistant Dean, the Head of Departments, Head of Unit, lecturers and participants, and all these organizing committee for the 23rd Medical and Health Research Week. A very welcome to all of you indeed. It's a great honor and pleasure that we can still have 23rd Medical and Health Research Week this morning. And the themes of this year is Beyond the Pandemic, Rising for Healthcare and Research. All praise to Almighty Allah that in the midst of COVID-19 pandemic, we still can have this research event, and of course through the different media. And I think in this era, one has to change. If not, we will be changed by the whatever scenario that we are facing with. I think I would like to express my utmost gratitude to all this organizing committee, members in the Faculty of Medicine for their efforts, coordinating, arranging, brainstorming to have this event today. Of course, adaptation to the new norm for the research meeting like this, also to ensure participants and researchers are still able to learn and conducting research in the right way. Despite the challenges, the issues, problems that we have Either one is practicing lab-based or community-based or whatever type of research. I think having resilience in this era is very important. Having a strategy, having really sit down, optimizing the time, even during the weekend, we have to squeeze ourselves to come to do lab work if needs to be done. Otherwise, we are lagging behind and we will fall behind. The pandemic will be winning toward us. Let me share a screen for a few things that I want to share with all of you. Just give me a moment. I'm not sure why I cannot share here. This is very common complication of the digital or meeting, but never mind. So what I'm going to say now is one has to have a resilient mindset when performing research, changing from protection to the opportunity, changing from not only as an expert, but also have a mindset of curiosity, changing from the reactive to be proactive and creative in performing research, becoming a new agent for the research, becoming abundance and continuing to explore, and a resilient growth mindset for the research arena, rather than just, oh, this is pandemic, let's sit down and change the research strategy and do something not useful. But I think quite important for us to have the resilient research mindset. And organization also struggling how to collaborate. Is this the what we call this misaligned type of organization, or is it isolated networks? But I think one has to consider to prioritize all these relevant stakeholders that involve in doing research. So I think quite important in this era that our mindset is focused on our niche area, our focus not to easily deviated by many other aspects, in particular COVID-19 pandemic. And I think we all know the research as very important, whether you want to be a lecturer, whether you want to be administrator, whether you want to be clinician or want to be anything. Research is your selling point. Research is one of the critical factors for career progression. Research is about a selling point for you to sell to the community, to sell to the government, to sell to the industry or university, or you can say that as the quadruple helix framework about the findings, the output that you have, showing your strength and capability in the focus area that you're going to do. So you have to determine what you want to do. Don't put your position neither here nor there. You want to talk everything about research, but you must find a focus area, what you want to explore or deep dive in that particular area. And believe me, once you are a good researcher, you can be good in many things, in managing of finance, managing in social economic aspect, managing presentation skills and many other aspects. And research tell us that the ideas that we want to share with others, the innovation and creativity that we're going to produce is becoming very important, very fundamental to the community. And it is very important for us to absolutely focus or has 100% attention to the research in the way that we need to do. I mean, let me give example. If we are in the area or ecosystem of medicine, we cannot forget about other aspect, which is nowadays, for example, the 8 essential technologies that we need to have in order for research to progress. Internet of Things, drones, robotic, artificial intelligence, augmented reality, visual reality, all this aspect, deep machine learning, all the aspect is very important for us in order to progress our research area. Research, whatever that we do today or last year or tomorrow may be obsolete in few years' time, because there are technology that drive the research, what we have done today becoming irrelevant. So something that we need to keep in mind, the rest of the world, in the Western world, in the Middle East, in the Far East, what area of research that we should be involved, And research involves many things. Research involves the original ideas. It's not R&D. R&D here, read and duplication. We do not want to read someone else's research and we duplicate to suit into Malaysia ecosystem. It's not like that. It's more read and duplication. It's really research and development. It's new ideas, novelty aspect. What are the emerging aspect? If I want to focus in my area, like it or not, the gut microbiota now is one of the emerging research thing that I need to explore in details, but still focusing on the research niche. Same again, many machine, many equipments, all these NGS are very important aspect of research. I think we all know this COVID-19 pandemic really trouble of us. Really a tragedy all over the world, and with all this movement control order restriction, make it very difficult for students and lecturers to attend research progress or to attend the lab. But I think we have to be very creative. We have to very innovative. We still can meet, let's say, in the Zoom platform. We can still doing a research progress. The student can have a timetable to do whatever need to do in the lab. Following the SOP so that the work can progress. But I think, as we all know, we are successfully fighting the influenza back in early 1900, nearly more than 100 years ago. And I have no doubt we are going to beat COVID-19 as well. Time will tell us. And I'm sure with the research that we involve, and I have to thank to the Faculty of Medicine, the management, allowing funding to do some research in COVID-19. And I think one of the days, based on the program here, the researcher involved in the COVID-19 will showcase their findings to all of us. And I also like to thank all the speakers. We have Prof. Emeritus Datuk Wan Zurina, Prof. Datin Nolina, Prof. Zaleha, Prof. Issa Naina, Prof. Datuk Fuad, Prof. Dr. Muhammad Rahim, Prof. Tong, Prof. Azmi, and many more who are involved as speakers and giving their insight, their experience about all the conducting and coordinating research here. And I would like also to thank and to congratulate really the winners of the Researcher of the Year that will be announced by the chairman of the 23rd Medical Health Research Week later, Dr. Muhammad Haikal, and looking forward for the presentation and what we can learn from the best brain in the faculty here. I think with the initiative that outlined by the Vice Chancellor, relevant into the Faculty of Medicine, how this Teras and 25 initiative with the two big things, income generation and graduate implementability are well ahead or well informed in our faculty. But I think we also need to shift our mindset that the research also can bring the revenue. The research, the high quality research can bring the capital to the faculty or to any institution. And I also would like to highlight, we also need to be a cost cutter skill. We have to have a cost cutter strategies. Despite the limitation of the resources or anything that in the lab where we are really have limited, but we still manage to produce the output which is comparable with the researchers all over the world. So increase enhancing revenue and have a cost cutter strategies very important aspect for the researcher to have in mind, not only keep doing something that we need to do. And the other aspect is try to uplift the research so that there will be a commercialization at the end of the day of the research. We can produce hundreds of papers, but again, at the end of the day, people will look at IP and intellectual property and patents, so and so, rather than just a typical review of literature and typical review here and there. Must be a variety or variations of the research element or publication that we can showcase to the world, in particular to the peers, ranging from a simple case report to original research articles, to mini review or extensive comprehensive reviews, letter to the editors, and so and so. And collaboration is very important. In this era, no one can do research on his or on her own anymore. The spirit of collaboration is very important. If someone venture, let's say, in biochemistry or anatomy or physiology, one has to look about the microengineering point of view. One has to look at the socioeconomic point of view. One has to look in other disciplines that involve directly or indirectly to the research. So I think, again, I must congratulate to all the organizing committee and the chairperson for consistent. The show must go on despite the COVID, and we managed to do that today. And I think for the next week or two, there are many exciting programs. Finish off with the morning coffee with international distinguished professor. And I hope all the participants and researchers enjoy be virtually in this meeting. And without further ado, I would like to welcome all the participants and researchers to the 23rd Medical and Health Research Week. And I would like to officiate this MPP with Bismillahirrahmanirrahim. May we have fruitful discussion for the next couple of days and weeks. With that, thank you so much for your attention. And I pass back the stage to the chairperson, Dr. Muhammad Luqman. Off you go, Dr. Muhammad Luqman.
Thank you very much. And we humbly thank you, Professor Raja Effendi Raja Ali, for his welcoming remarks, as well as appreciating the ceremony. Thank you for that. Now, to continue with our program, ladies and gentlemen, it is an absolute honor to bring to the stage, or to the screen, and welcome the Vice Chancellor of UKM, His Excellency Professor Technologist Dr. Muhammad Ikhwan Haji Toriman, to deliver his opening address. Please welcome the Vice Chancellor to the screen.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. Yang Mulia Profesor Dr. Raja Effendi Raja Ali, Dean Faculty of Medicine UKM, Professor Dr. Tan Yok Chin, Deputy Dean Research and Innovation, Faculty of Medicine UKM, representative, distinguished guests, ladies and gentlemen. It gives me a great pleasure to welcome you to the 23rd Medical and Health Research Week. Last year, we hosted the 22nd Medical and Research Weeks in a fully virtual format for the first time, and it was a huge success. I'm very pleased that this year's Research Week will commence in a similar format due to the ongoing COVID-19 pandemic. I would like to express my appreciations to the Faculty of Medicine for hosting this Research Week and for bringing us together on this day to build upon what we have accomplished in the past year. Throughout this Research Week, you will explore more opportunities to produce high-quality research with a significant impact on community. Health and medical research contribute to improve health and well-being through disease discovery, treatments, and preventions. Health and medical research in particular have aided in the improvement of health services and the well-being of people all over the world. This Research Week is critical in allowing researchers and postgraduate students to explore while sharing ideas and knowledge in order to achieve more desirable research results. Not only is research focused on developing the most effective treatments for specific diseases, but it is also crucial for early detections of any disease, as the saying goes, prevention is better than cure. Medical and Health Research Week has been organized annually since 1999, aiming at exposing postgraduate students to research skills in a centered environment provided by the faculty and university. It is our effort as an institution to increase training in research methods, including research management, in order to strengthen networking among faculties, institutes and centres at University Kebangsaan Malaysia, as well as with other local and international universities. Ladies and gentlemen, I am confident that this event will achieve its objectives, which include the following: to familiarize participants with the components of research methodologies and the essential paperwork preparation for clinical and experimental research, to educate participants about current issues in research skill developments through a series of thematic talks, and to foster research collaborations and disseminate research findings through Foster's competitions. On these occasions, I would also like to congratulate the Faculty of Medicine for successfully implementing this event online. From what I have heard, has received an extremely encouraging response from young researchers and postgraduate students. This proves that despite the fact that we are in a critical situation due to the COVID-19 pandemic, the faculty is able to gather a strong teams capable of being creative and innovative in implementing research programs and activities for the participants and researchers. I also hope that similar programs will be carried out from time to time to encourage young researchers and postgraduate students to pursue their research. I am confident that panelists from both local and international speakers will provide an in-depth discussions and useful tips throughout the events. I hope everyone will have a fruitful discussions, and may all of your research meet the desired objectives. With that, I now declare the 23rd Medical and Health Research Week is officially open. Thank you.
With that, thank you. We humbly thank His Excellency for his thoughtful speech and officiating the ceremony. We shall now continue with a short montage presentation as prepared by the Welcoming Committee before proceeding with the following event. Moving onwards, it is my utmost pleasure, ladies and gentlemen, to invite to the floor the Honorable Professor Emeritus Datuk Dr. Wan Zurina Wan Yang to officially introduce our Researcher of the Year. Ladies and gentlemen, please give a warm welcome to the Professor. Thank you very much.
Thank you, Dr. Muhammad Lokman as Chairman. Yang berbahagia, Profesor Dato' Technologist Dato' Dr. Muhammad Ikhwan Toriman, Vice Chancellor of Universiti Kebangsaan Malaysia. Yang Mulia Profesor Dr. Raja Effendi, Dr. Raja Ali, Dekan Fakulti Perubatan. Yang berusaha, yang berbahagia, Prof. Dr. Tan George Chin, Deputy Dean of Research, Dr. Muhammad Aikal Yunus, selaku pengerusi 23rd Medical and Health Research Week, and honorable guests and participants. Thank you. It is indeed a great honor and pleasure for me to introduce to you the Researcher of the Year 2021, Professor Suzana Makpol, a very dear friend. Professor Suzana Makpol graduated from UKM, is Professor of Biochemistry at the Medical Faculty of Medicine, UKM, and graduated from UKM as well, with both her undergraduate degree as well as her PhD. She went on to do some attachments in Hokkaido in the year 2000 and at Linus Pauling Institute in the US. And she was head of biochemistry for 7 years, from 2011 to 2018, and is currently the head of the Aging and Degenerative Disease Research Group. She has received many awards, including the Excellent Service Awards 4 times in 2018, 2012, and 2026 and 2003. She was also awarded the Johan Setia Mahkota by Sri Paduka Baginda Yang Di-Pertuan Agong. Professor Dr. Suzana has great passion for research and has secured more than 5.32 million of grants as principal investigator. Her main interest in research is with aging and degenerative diseases, which affects all of us, unfortunately. But she focuses on cellular senescence and its modulation by antioxidants such as palm tocotrienols, microalgae, Chlorella vulgaris, Kelam honey, piper betel, and Zingiber officially. She has studied using cells in culture as well as animal models and human studies. For her research, she has been recognized and awarded several awards, such as the Anugerah Sanjungan Kencana Research Award for individual this year, the JT Award for Tech Planter Demo Day in Malaysia 2017, and Silver Medal Age Innovasi UKM 2017. She's a prolific writer and has published over 100 papers in peer-reviewed international journals and presented more than 190 seminar papers as recognition of her contribution to research. She's also very active in supervising students and has currently graduated more than 50 PhD and Masters of Science students. She is also recognized internationally as she has been invited to evaluate international research grants, which include the Junior and Senior Research Project for the Research Foundation Flanders of European Science Foundation and the Polar National Science Centre grant. She's also a member of the Evaluation Committee for Ministry of Higher Education, for Ministry of Science and Technology and Innovation, as well as for other local universities, both public as well as private universities. She is very experienced also in teaching undergraduate students, as evidenced by her invitation to become excellent examiners in most of the local universities now in Malaysia. And she's also been invited to examine thesis for both masters and PhD by other local universities such as USM, UPM, UITM, and UCSI, as well as being external assessor for our local universities, both and international universities. She is a very special lady to me. She was my student and I've known her since 1994, I think. And she's a very close friend. We could have friends even from a different generation. So she's a different generation friend. Ladies and gentlemen, please welcome Prof. Susanna Makpol to deliver her talk as Researcher of the Year 2021. Thank you. Dr. Lokman.
Thank you, Professor Emeritus Dr. Wan Zurinah Wania, for your kind introduction. Professor Dr. Wan Zurinah was my supervisor for PhD, as she mentioned earlier, and she is also my mentor in research. So, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and salam sejahtera. His Excellency Professor Dr. Technologist Muhammad Ikhwan Haji Toriman, the Vice Chancellor of UKM, His Highness Professor Dr. Raja Afandi Raja Ali, the Dean of the Faculty of Medicine UKM, the Honorable Dr. Muhammad Haikal Muhammad Yunus, Chairman for the 23rd Medicine and Health Research Week, distinguished professors, fellow lecturers and participants, ladies and gentlemen. Alhamdulillah, my gratitude to Allah Subhanahu wa Ta'ala. Okay, and I also would like to take this opportunity to thank His Highness Professor Dr. Raja Afandi Raja Ali, the Dean of the Faculty of Medicine, and the Honorable Dr. Muhammad Haikal Muhammad Yunus, Chairman for the 23rd Medicine and Health Research Week, for this award. And this morning, I'm going to share my research journey in UKM, focusing on cellular senescence in aging and its modulation by antioxidant. So let me share my slide first. Okay. My research focus, as mentioned earlier in the introduction, is on cellular senescence in aging and its modulation by antioxidant. A little bit on the introduction. Okay, there are several theories of aging, and among the acceptable theories is the free radical theory of aging. Over passage of time, there will be accumulation of free radicals. There will be accumulation of reactive oxygen species from due to the presence of exogenous factors, or the free radicals and reactive oxygen species produced endogenously. And this reactive oxygen species, when it is accumulated in the cells, it can cause molecular injury to the DNA, protein, and lipids, and subsequently damage major organelles in the cells, such as the mitochondria and peroxisomes. And the damaged organelle will activate cellular responses, such as inflammation, proliferation, and finally can also cause death or a programmed cell death known as apoptosis. In terms of the systematic responses, okay, it can result to aging, organ dysfunction, frailty, and diseases. Accumulation of reactive oxygen species also can activate the modulation of signal transduction pathways. As we know, there are many signal transduction pathways in the cells, which can lead to the changes in gene expression and result in cellular responses, and finally results to aging and diseases. When cells age, okay, the process is known as cellular senescence. So cellular senescence is a process that imposes permanent proliferative arrest on cells in response to various stressors. The stressors can be shortening in the telomere, damage to the DNA, oxidative stress, okay, so on and so forth. And this cellular senescence potentially important contributor to aging and age-related disease. And when cells undergo cellular senescence, it will exhibit metabolic and functional changes characterized by cell cycle arrest. So when cells are arrested, it will be in the G0, G1 phase of the cell cycle. And it will also acquire a pro-inflammatory phenotype secreting cytokines, growth factors, metalloproteinases, and reactive oxygen species. And cellular senescence or senescent cells will accumulate with aging. But what is important, okay? The senescent cell can convert neighboring cells to senescence in a paracrine manner. So this is the summary in terms of the process. What happened during cellular senescence and its consequences. So it starts from one of the factors is telomere shortening, as well as other stresses, as I mentioned earlier, which will activate signaling pathways. And the damage to the DNA will promote cells to be growth arrested. A cell can no longer divide. It will stay at the G0, G1 phase of the cell cycle, and it becomes senescent. So senescent cells, the major characteristic of senescent cells is it will secrete senescence-associated secretory phenotype, which includes cytokines, chemokines, proteases, and growth factors. Senescent cell also will secrete senescence-associated beta-galactosidase enzyme, and this is one of the most important enzymes which act as a biomarker for cellular senescence. The accumulation of senescence cell can occur, and as I said earlier, senescent cell can convert neighboring cells to senesce in a paracrine manner. Therefore, when there is accumulation of senescent cells, it can finally result to organ dysfunction, which consequently can result to aging phenotype and chronic diseases. How is this occur? One of it is through the propagation of inflammation and also dysregulation of metabolic processes in the cells. But if this process can be inhibited or slowed down? The answer is yes. Okay, most of the literatures mention that healthy lifestyle, balanced diet, and doing regular exercise can slow down the process of cellular senescence. And recently, there were also reports which mention the presence of senolytic agents, which can also inhibit or delay the formation of senescent cells. So what are senolytic agents? Okay, so senolytic agents are compounds that can selectively induce apoptosis of senescent cells. And as we know, apoptosis is cell death. Okay, so senolytic agents can selectively induce apoptosis of senescent cells. Therefore, finally, okay, the organ dysfunction can be slowed down, and also prevention of aging and chronic diseases. A few studies have reported the role of senescent cells and SASP, or senescence-associated secretory phenotype, in aging and degenerative diseases. Lee, in 2019, in his paper, reported that chronic inflammation induced by SASP might be the major underlying cause of many age-related diseases. Okay? And there was also paper reported the role of cellular senescence, which can be used as a promising strategy for cancer therapy. Cellular senescence also play a big role in the formation of endocrine diseases, which include osteoporosis, metabolic syndrome, and type 2 diabetes mellitus, as well as other endocrine conditions. And there is one important protein, which is always expressed when cells undergo cellular senescence, and the protein is known as P16 protein. And this P16 INK4A proteins are proteins involved in the regulation of cell cycle. And this protein will work together with P53 cells, which later can result to cells to be growth arrested. As for our work in UKM, our work on cellular senescence and its modulation by tocotrienols was first published in year 2010 in a Q2 journal. And subsequently after that, we just move forward, focusing in the same research area and producing more papers. So the focus is directly on cellular senescence, on how it is modulated by various types of antioxidant containing compounds. So these are all the papers, that is very much focused to the cellular senescence and how it is modulated by various types of antioxidant compounds. So I just go a bit more detail on our findings, but I'll be focusing more on the in vitro study. So for cellular senescence, as I mentioned earlier, the model that is normally used is human diploid fibroblasts. So we extracted human diploid fibroblasts from the foreskin of small children, 9 to 12 years old, who undergo circumcision. So as can we see from the microscope, from the in vitro study, young cells exhibit spindle-shaped cells. But when it senesces, when it undergoes cellular senescence, the cells become enlarged and threatened, with the presence of a senescence biomarker, which is senescence-associated beta-galactosidase. And when we measured the level of expression of this enzyme, it was significantly higher. It was significantly higher in the senescent group of cells. For the phases of the cell cycle, we found that senescent cells were mainly in the G0, G1 phase. So this is the G0, G1 phase of the cell cycle, with less cells present in the S and G2, M phase. But with the treatment of antioxidants, so for an example, in this study, we use palm tocotrienol as the source of antioxidant. And we found that in senescent cells, the percentage of cells in the G0, G1 phase was reduced with the treatment of antioxidant, while the G2M phase was increased. The expression of senescence-associated genes were also studied. So there are several genes that are involved in cellular senescence, such as the matrix metalloproteinases. One example is the MMP1, and there are also other genes such as collagen type 1, elastin, interleukin 6, cyclin B1, and RB. So these two proteins are involved in the regulation of the cycles. Some of the genes, like MMP1 was significantly higher in senescent cells. Similarly, interleukin 6, interleukin 6 is also higher in senescent cells, as well as cyclin B1 and retinoblastoma protein gene. And with antioxidant treatment, we can see that there is suppression in terms of the expression of this gene. MMP1 was significantly decreased, as well as the interleukin 6, cyclin B1 and RB, which was suppressed in terms of its expression. While collagen type 1, collagen type 1 was significantly increased in cellular senescence with antioxidant treatment. Next, we also measured the percentage of DNA damage in the cell by doing format assay. And of course, we found that in senescent cells, there was a high, the DNA was highly damaged. Okay, the DNA was highly damaged, but this damage was actually improved when the cells were treated with antioxidants. So in terms of the marker for the cellular senescence, which is senescence-associated beta-galactosidase, so this has been proven earlier, whereby the senescent cells exhibited increased expression of senescence-associated beta-galactosidase, and this enzyme was suppressed with the treatment of antioxidant. We also developed our own model, okay, which is known as stress-induced premature senescence model, by introducing hydrogen peroxides in the cell culture. And we found that in the model that we developed, the young cells, when it was exposed to hydrogen peroxide, it exhibited cellular senescence characteristics, okay, with higher percentage of senescence-associated beta-galactosidase, as well as increased percentage of cells in the G0, G1 phase, and decreased percentage of cells in the S phase and in G2M phase. Okay, another important characteristic in senescent cell is telomere. Okay, so as we know, telomere is the sequence of nucleotides at the end of a chromosome, and it functions to protect the genome from nucleolytic degradation. And this telomere will be shortened every time cells divide. However, the length of the telomere is maintained by the presence of an enzyme known as telomerase. So, in terms of the telomere length and telomerase activity in cellular senescence, we found that when cells undergo cellular senescence, the length of the telomere was significantly shortened, as well as the activity of the telomerase enzyme, which was significantly decreased. We then proceed by doing differential gene expression analysis by using microarray platform, and we found that the genes were significantly differentially expressed when it was compared between senescent cells and young cells. So there was a clear separation in terms of differentially expressed genes in the senescent cell as compared to the young cells. And when these cells were treated with antioxidants, there were certain pathways which were affected, okay, such as the biological pathways, which involve in the negative regulation of tumor necrosis factor production, the negative regulation of interleukin-6 production, the pathways involved in the negative regulation of caspase activity. And we know that this caspase is one of the important enzymes in apoptosis pathway, as well as the biological processes, such as pathways involved in response to stress, for protein transport, and also for cell redox homeostasis. We then go deeper, okay, into the proteins involved in the signaling pathways. So we focus on the cell proliferation pathway. We measure the expression of the genes and proteins such as AKT, FOXO, CDKN1A, ELK1, ERK, RSK1, FOS, SIRT1, okay? And we found that there were different expression of these genes with senescence, which was modulated by tocotrienol treatment. Okay, not only the genes were affected, but also the proteins. So the proteins were determined by using Western blot technique. So again, okay, we focus on more signaling pathway. So now it's on the insulin-associated signaling pathway, the DNA damage pathway, as well as the cell differentiation signaling pathways. So more genes, the expression of more genes were determined. So now the genes such as SOD1, SOD2, the CCS1, pyridoxine gene, catalase, glutathione peroxidase, again FOXO, the DNA damage gene, which is TP53, PAX2, and CDKN2A, MAP kinase, okay, MAP kinase 14, and JUN. So again, we found that there was differential expression of these genes with cellular senescence, which was modulated by antioxidant treatment. As I mentioned earlier, P16 is one of the important genes in the regulation of cell cycle. So in the subsequent study, because earlier we found that this P16 protein was highly expressed in senescent cells. Okay, so this is the level of the P16 expression. Okay, the P16 gene expression in senescent cells. So what we did is we suppressed the expression of this gene by introducing small interference RNA, okay, or SIRNA, small interference RNA. So the expression of P16 INK4A gene was suppressed, and interestingly, when this gene was suppressed, we found that morphologically, okay, the senescent cells exhibited the morphology of the young cells. So this is this diagram, or this photomicrograph shows the morphology of young cells, and this one is the morphology of the senescent cells, which was enlarged and flattened. And when this P16 INK4 gene was suppressed, the morphology becomes like the young cell. Okay, the cells are more spindle shaped, more percentage of cells are present in a spindle shaped form. So this shows actually during cellular senescence, one of the important gene or proteins that plays a big role is actually P16 INK4A through the activation by TP53. We then move on to looking at the role of senescence-associated microRNAs. MicroRNA are non-coding RNA. Okay? MicroRNA are non-coding RNA that play important roles in regulating gene expression. Okay? It is present as a single-stranded RNA, and it interacts with the 3' untranslated region of the target mRNAs to induce mRNA degradation and also translational repression. But under certain conditions, microRNA can activate translation or regulate transcription. And the interaction of microRNA with target gene is dynamic. Therefore, we studied the expression of a few microRNAs that we thought may regulate the downstream genes that are involved in cellular senescence. So what we found from this study was upregulation of microRNA 24 and microRNA 34A, and downregulation of microRNA 20A and microRNA 449A in senescent HDF, okay? In senescent human diploid fibroblast. And when the cells were treated with antioxidant, and in this study, again, we use pump Tokoh triennial fraction, and we found that this antioxidant reduced the expression of microRNA 34A in senescent cells and increased microRNA 20A expression in young cells, as well as increased microRNA 449A expression in both young and senescent HDF. So the main thing here is actually decreased expression of microRNA 34A, okay, in young cells. So subsequently, we transfect the cells with microRNA 34A to induce ectopic expression of this microRNA 34A in young cells. So what we found was that when the cells were ectopically transfected with this microRNA, the morphology of the cells become like senescent cells with reduced expression of cyclin-dependent kinase 4. And we know the cyclin-dependent kinase 4 protein is one of the important protein in the regulation of cell cycle. And when antioxidant was introduced to the cells, the expression of this microRNA was inhibited. Thus, it relieved the inhibition on the CDK4 gene expression. So this finding was actually very interesting because it shows the role of microRNA in regulating the downstream genes, which subsequently results to the final regulation of the cell cycle profile. We then move on into doing proteomic profiling. Okay? So proteomic profiling in cellular senescence was carried out, and we found that a total of 1,217 proteins were identified in young and senescent cells, while another 1,218 proteins were identified in vehicle and also in gamma tocotrienol treated cells, or in antioxidant treated senescent cells. So this is the list of differentially expressed proteins, okay, in young and senescent cells. So these are the proteins which were differentially expressed, okay, when cell senesced. So 11 proteins were found to be differentially expressed when we were comparing between young and senescent cells, okay, and there was downregulation of platelet-derived growth factor receptor beta protein, as well as upregulation of tubulin beta-2A chain protein expression in senescent cells. And for the cells treated with antioxidant, we found that there were 51 differentially expressed proteins identified with the upregulation of the heat shock protein, triose phosphate isomerase, and malate dehydrogenase protein. Okay, so these are the list of the proteins. In terms of the pathway analysis, okay, so we found that the PDGF, platelet-derived growth factor signaling, and also the cytoskeletal structure may be dysregulated, okay, in senescent cells as compared to the young cells. And treatment with antioxidants was shown to promote proliferation, okay, by promoting the expression of the proteins involved in the signaling pathway. Okay, so that was the study by using human diploid fibroblasts. We then move to using human myoblasts. Okay, so primary human myoblasts from female Caucasian, age 17 years old, was used in the study and divided into 3 age groups: young with population doubling less than 15, pre-senescent at population doubling between 18 to 19, and senescent with population doubling more than 20. So the cellular senescence was confirmed, okay, by measuring the expression of senescence-associated beta-galactosidase. And the purity of the cells, okay, was also confirmed by doing Desmin staining. So from this data, okay, above 95% of the cells present in the culture was actually human myoblasts, okay, and there is little presence of other type of cells in our culture. The senescence biomarker, which is senescence-associated beta-galactosidase, okay, based from the staining here, was measured. So the senescence, the expression of the senescence biomarker was increased with increment in total population doubling. We also measured the rate of proliferation by doing the RDO analysis. So of course, with the increment of population doubling, okay, the proliferation rate decreases. So this is the expression of the senescence biomarker in the cells with and without antioxidants treatment. So as we can see here, in myoblasts, which already undergo cellular senescence, the expression of senescence-associated beta-galactosidase was significantly increased. And with the treatment by different types of antioxidants, okay, TRF is tocotrienol rich fraction, ATF is alpha tocopherol, so these are the two natural compounds. But we also studied other commercially available synthetic antioxidant, which is N-acetylcysteine. So from our study, we found that this antioxidant was managed to reduce the expression of senescence-associated beta-galactosidase, which is the marker for cellular senescence. So this is the myoblast morphology observation under the microscope. So as you can see here, okay, the blue dot indicates the nucleus, okay, while the green staining, Desmin staining, indicates the cytoplasm of the cells. So when myoblasts were young, okay, the morphology is like it has a spindle shape morphology, and when the cells undergo cellular senescence, it becomes more flattened and enlarged. So senescent myoblasts display an enlarged and flattened morphology with the presence of more intermediate filament networks. Okay, and also there is elevated extracellular matrix degradation and excessive protein loss cause failure in the ultrastructural preservation, consequently presenting the unique morphology of senescent cells. Okay, so this actually observed clearly in terms of the morphology of the cells when the cells undergo cellular senescence. And myoblasts, in terms of the characteristic, okay, myoblasts will, we confirm the size of the myoblast, okay, whether it is enlarged or not by measuring the size of the myoblast itself. And of course, quantitative data showed that the size of the myoblast was increased when the cells were senesced, okay, and treatment with different types of antioxidants was able to reduce the size of the myoblast. And treated senescent myoblasts also resemble the young morphology with more spindle-shaped cells, suggesting the potential of this treatment in preventing cellular senescence. And these findings was already published in PLOS ONE in 2016. So as I mentioned in my first slide, okay, during with increased passage of time, there will be increase in reactive oxygen species accumulation. Okay, so we measured that the level of reactive oxygen species by using flow cytometry technique. We perform two types of staining, okay, DHE staining to measure the presence of superoxide anion, while the other staining, which is carboxy H2D CFDA, which will measure the presence of hydrogen peroxide, peroxynitride, or hydroxyl radical. So, and this was converted to a quantitative data, and we found that in senescent, there was a significant increase in the intracellular ROS generation. Okay? And with antioxidant treatments, the level of the intracellular ROS generation was significantly decreased. So as we know, reactive oxygen species will attack other macromolecules such as DNA, lipid, and proteins. So we measured the lipid peroxidation process, okay, by using this staining. So this is also from the flow cytometric analysis. So the dye that was used in this study was BODP. Okay? So this dye, okay, it can turn from green to red when there is oxidation occurs in the cell. Or it can also turn from red to green when there is reduction process occurs in the cell. Therefore, from this flow cytometric analysis, we get the quantitative data, which is the ratio of oxidized to reduced dye. Okay? And from here, it was shown that when cell undergo cellular senescence, there was significantly increase in lipid peroxidation. And this lipid peroxidation was elevated, okay, when the cells were treated with different types of antioxidants. Next, okay, it's about the formation of myotubes from myoblasts. Okay, naturally, okay, these myoblasts or muscle cells will differentiate to form myotubes. So this is the myotubes that we observe from our in vitro study. Okay, the myoblast cells fuse together and form myotube. So the formation of myotubes was very good and clear, okay, clear and good in senescent cells. But of course, it was not so efficient, okay, in senescent cells. So aging affects the differentiation potential of human myoblasts, as shown from this study. As when cells undergo cellular senescence, the formation of myotubes was no longer efficient. So how do we measure the formation of myotubes? Is by having these two parameters, which are fusion index and the size of myotubes. So from the fusion index, okay, we significantly showed that the fusion index was significantly reduced, okay, in senescent cell, but it was increased when the cells were treated with antioxidant. A similar decrease was observed in the size of myotube. When cells undergo cellular senescence, the size of myotube decreases. Okay, so in the myoblast, there were also myomas that we determine in terms of its expression. So myomas are microRNA present in the myoblast. So we measured the expression of different types of myomas, such as MIR133B, MIR206, and MIR406. Because again, we want to look at the effect of these myomas or microRNA in the myoblast on the downstream genes involved in the regulation of cell cycle in the myoblast cells. So we measured the expression of the myomas as well as the expression of the different genes such as PAC7, P10, and also IGF-1R genes, which are involved in the regulation of cell cycle in myoblast as well as involved in the differentiation of myoblasts to form myotubes. So we also measured again the cell cycle profile. So again, there was improvement in terms of the percentage of cells in the G0, G1 phase with the antioxidant treatment and increase in the cells in the S phase with antioxidant treatment. Okay. And just recently, okay, we published our data in terms of the expression of proliferation marker, which was K1, Ki67, and differentiation marker, MyoD. So this again confirms the role of this marker in myoblast differentiation and how the expression of this marker was modulated by antioxidant treatment. And another marker which will show or indicate the efficacy of myogenic differentiation was measured. So similar finding was observed whereby this marker, the expression of this protein was decreased in cellular senescence but was improved or increased with the treatment of antioxidant. So besides looking at the effect of tocotrienol, which has got high antioxidant property, another compound that has good potential and has been shown to have high antioxidant property is zingiber officinale roscoe. Zingiber officinale roscoe, or commonly known as ginger, okay? From this study shows that it improves myoblast regenerative capacity. Okay, so this is from the senescence-associated beta-galactosidase staining. So we can see that the SA beta-galactosidase was increased in senescent cell, but decreases with the treatment of antioxidant, which is the ginger, okay, as in this study. As well as it promotes myoblast differentiation. So for conclusion and the way forward, okay. So from our study, the fundamental mechanism of cellular senescence and how is this cellular senescence can be modulated by antioxidants has been elucidated from the morphological study, from the determination of senescence-associated beta-galactosidase marker, from the expression of SASP or senescence-associated secretory phenotype, which includes cytokines and chemokines, the cell cycle profile, the expression, global gene expression through the microRNA analysis, as well as the global proteomic analysis, so for the senescence-associated proteins, the microRNAs in the human diploid fibroblasts, as well as the myomas or microRNA in the human myoblast. We also relate this mechanism with the activation of the apoptotic pathway and also measuring the expression of oxidative stress markers, okay, and also inflammatory markers. So the basic fundamental mechanism for cellular senescence has been elucidated. We then try to intervene in the process by introducing various natural compounds such as palm tocotrienols. So from our study, okay, we did not only the study by using cell in culture, but animal study was also already performed, as well as human study. Therefore, in terms of the way forward, okay, recently we have got research grant to do phase 2 clinical trials. Okay? So in the phase 2 clinical trials, we'll be focusing on the expression of SASP, the inflammatory markers, the oxidative stress markers. We're also going to measure the mitochondrial function. As we know, when there is accumulation of free radicals and reactive oxygen species, it can also affect the function of the organelle, the bone integrity, vascular function, and skin health. So this will be carried out as a phase 2 clinical trial from the industrial grant that we have just received. As for the second natural compound that I will study, zingiber officinale, roscoe of ginger. So currently, the study by using cell in culture has been completed, okay, as well as the study by using the animal. But for human study, we are still having an ongoing pilot study to study the efficacy of this ginger capsule on the elderly. So the way forward, okay, is to develop health supplements, okay, health supplements from subcritical water extraction of ginger, and Alhamdulillah, we have secured a PRGS research grant. And for this development of health supplements, we'll be focusing on the muscle function and strength, the bone integrity, and also cognitive function to study the efficacy of the product that we are going to develop. And another compound that has got potential as a senolytic, okay, is Chlorella vulgaris. Okay, Chlorella vulgaris is microalgae, and so far we have done the study for cell in culture as well as animal study. Okay, so that is about the journey of my research. Okay, very focused. Okay, initially, when I joined as a lecturer, I was like doing human study, focusing more on genetic polymorphism. And I was having difficulty in recruiting the subjects, in getting the correct number of samples. And subsequently, I chose to study cellular senescence. So that is actually the research focus now, and that is actually the way forward. Okay? And of course, at the end, I would like to give an acknowledgement. First is to University Kebangsaan Malaysia for the support, okay, for the research grant that I have got, okay, to the faculty for supporting with the publication fee, okay, to the other grant funders, okay, grant funders like MOSTI, which provided the e-science grant, KPT for the FRGS, LRGS, and also PRGS research grant. Our co-collaborators such as SAMDABI, MPOB, okay, as well as our co-researchers, okay, our co-researchers from UKM, from the faculty, as well as from other institutions. And of course, my biggest gratitude to my postgraduate students, okay? So the results that I presented earlier were extracted from the thesis of these students, okay? The masters and PhD students that were under my supervision. So with that, I would like to thank you for your attention.
Thank you. Thank you very much. Thank you very much for the excellent presentation and the focused outline of the whole research our Researcher of the Year. Just before we finish off the ceremony, I would like to invite the director for this year's 23rd Medicine and Health Research Week, the Honorable Dr. Muhammad Haikal, to extend the prestigious Researcher of the Year plaque to our guest of honor, Professor Dr. Suzana Makpo. Please give a warm welcome to Dr. Haikal and Prof. Suzana. Thank you. Thank you very much again, and a hearty congratulations to Professor Dr. Suzana Makpo for winning this auspicious and prestigious award. Yeah. So with that, ladies and gentlemen, we would like to extend our gratitude to all the participants for attending this wonderful opening ceremony. We hope that everyone benefited the knowledge presented by our esteemed guest of honor, and hopefully would gain more knowledge in the days to come. So please remember, we shall begin our first module A tomorrow, developing a research proposal at 9 a.m. tomorrow. So thank you once again. And with that, I end the opening ceremony. Stay safe, everyone, and have a very productive week ahead. Thank you. Wabillahi tawfiq wal hidayah. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Thank you. Please remember for those of you about to scan especially for doctors, the CPD points. Okay, it starts today. Thank you very much. Have a good one.